Since Russia's full-scale invasion in 2022, the Ukrainian armed forces have continually uncovered new and increasingly effective ways to fend off their aggressors, demonstrating a level of innovation and adaptability that has astonished military observers around the world. While Ukraine has developed impressive modern weaponry, ranging from high-speed ballistic missiles and long-range cruise missiles to AI-assisted air defense systems, it has also found success by modernizing older technologies. One of the most striking examples of this has been Ukraine's reinvention of laser-guided munitions, a technology with roots in the Cold War, now updated for 21st century warfare. Understanding Ukraine's transformation of this technology first requires understanding how it works. Laser-guided weapons, as the name suggests, follow a laser beam to their targets. A laser designator illuminates a precise point on an enemy asset, creating a highly visible spot that a bomb or missile seeker head can detect and track, even from considerable distances. Once locked on, the munition homes in on that spot with exceptional accuracy, making laser-guided bombs among the most precise weapons ever developed. This kind of precision was revolutionary when it first appeared in the 1960s. Before then, air forces across the world struggled with accuracy, so much so that even massive bombing raids could miss their intended targets by miles. A British study during World War II revealed that only 1 in 3 bombers managed to land their payloads within 5 miles of a target, while U.S. research after the war found that even with advanced aiming systems like the Norden bomb sight, fewer than 1/3 of bombs hit within 1,000 feet. The waste of munitions and risk to air crews were enormous. Laser-guided bombs solved much of this problem. The first of their kind, the American Bolt 117, appeared in 1968. Although the technology was expensive and complex at the time, it laid the foundation for what would become a major leap forward in aerial warfare. By the 1980s, improved systems made laser-guided munitions a standard feature in many advanced militaries, and they soon saw extensive use in conflicts such as Operation Desert Storm in Iraq in 1991 and Operation Allied Force in Yugoslavia in 1999. These precision-guided munitions revolutionized military tactics by allowing forces to hit critical targets, enemy bunkers, command posts, or armored vehicles, with a single bomb instead of hundreds. They brought several major advantages: pinpoint accuracy in real time, reduced collateral damage, lower operational costs, and less exposure for pilots, since fewer sorties were needed to accomplish the same goals. Instead of the indiscriminate carpet bombing of earlier wars, laser-guided bombs made it possible to eliminate a specific enemy threat with surgical precision. However, the system wasn't without its flaws. The need for a designator meant that either a plane, vehicle, or soldier on the ground had to paint the target with a laser beam. If weather conditions, smoke, fog, or heavy cloud cover obscured the beam, the bomb could lose track. Later innovations like satellite-guided GPS munitions addressed some of these issues, allowing fire-and-forget strikes, but even GPS-based weapons are vulnerable to electronic warfare and jamming. That vulnerability has become particularly relevant on the modern battlefield in Ukraine, where Russia's sophisticated electronic warfare systems can interfere with GPS signals. Ukraine first adopted laser-guided systems in 2019 when it purchased Turkish Bayraktar TB2 drones along with lightweight laser-guided bombs such as the MAML and MAMC. The TB2 drones, which could both designate and deliver the bombs, became famous in the early months of the invasion for their devastating effectiveness. They destroyed Russian convoys, air defense systems, and naval assets, including in the high-profile battle for Snake Island. But as Russia learned to counter the TB2 and bolstered its air defenses, Ukraine had to adapt once again. Western allies soon supplied new generations of precision-guided bombs, such as France's AASM Hammer and the American JDAM ER and GBU-39. These weapons could use GPS or laser guidance, offering flexibility depending on the conditions. Yet with Russia jamming satellite systems, laser targeting has once again taken center stage. Ukrainian troops have grown highly skilled in operating laser-guided systems, notably the American AGR-20 Advanced Precision Kill Weapon System, APKWS, which turns standard Hydra 70 rockets into precision weapons guided by lasers. These rockets can strike both air and ground targets, and Ukrainian forces have even used them to shoot down Russia's Shahed drones. In 2024, Ukraine began deploying U.S.-supplied M712 Copperhead 155mm artillery shells, laser-guided rounds that can accurately strike targets up to 16 kilometers away. These systems have proven invaluable, but they share Because Ukraine's air force is small and faces intense Russian air defense coverage, keeping jets or helicopters in the sky long enough to guide bombs is often suicidal. But instead of giving up on laser-guided weapons, Ukrainian engineers and strategists did what they've done best throughout the war: innovate. Their solution was to shift the role of laser designation from aircraft to drones. Drones are smaller, cheaper, harder to detect, and expendable compared to manned aircraft. Ukraine's mastery of drone warfare has been widely acknowledged. It has used uncrewed aerial vehicles for reconnaissance, attack missions, and long-range strikes deep into Russian territory. Adapting drones to serve as laser designators was a natural next step. One of the leading developers in this field is FRDM, a Ukrainian defense technology company. In July 2025, FRDM's UAV-based laser guidance solution received official approval from the Ukrainian Ministry of Defense. The system consists of a 6.5 kilogram, 14-pound targeting module mounted on an R-34 quadcopter drone. Although the module's laser hardware is foreign-made, it fits perfectly with Ukraine's needs. It includes a designator to emit the beam, optical systems for visual tracking, and advanced software that keeps the laser fixed on the target. The system can engage targets up to 5 kilometers away, though weather conditions such as dust or fog may reduce range. According to FRDM representatives, including a developer named Anton, the system allows coordination between ground forces and aircraft. Infantry units can launch the drones, lock onto a target, and guide airdropped or artillery-fired munitions directly to it. These drones can assist helicopter attacks, JDAM strikes, and even other drones carrying small guided bombs. Anton emphasized that the system is built to work with NATO standard ammunition, a significant benefit since vast stockpiles of laser-guided munitions already exist across allied countries that support Ukraine. FRDM's CEO, Vadim Unik, noted another key advantage: cost. Western laser guidance technologies are expensive, but FRDM's drone-mounted systems offer a far more affordable alternative. As Unik explained, Ukraine needs large numbers of such systems to meet ongoing battlefield demands, and cost-effective domestic solutions will be critical to sustaining that supply. Operating these systems requires training and coordination. Each laser-guiding drone mission involves a 3-person crew, 2 pilots and 1 operator responsible for the laser itself. Missions last roughly 35 to 40 minutes, meaning efficiency and timing are vital. Still, this approach dramatically reduces risk to Ukrainian pilots and allows precision strikes even in heavily defended zones. FRDM isn't alone in pursuing this innovation. Another Ukrainian manufacturer, which specializes in fixed-wing reconnaissance drones and prefers to remain anonymous, has integrated its own laser guidance technology into UAVs currently deployed at the front. The company spent 2 years developing its system, which now supports artillery teams by providing laser targeting for precision strikes. These developments show that Ukraine's defense sector is becoming increasingly agile and capable of producing advanced, battlefield-ready systems domestically. Meanwhile, other firms are pushing the technology even further. Dwarf Engineering, a Ukrainian company known for its first-person view FPV attack drones, is upgrading its FPV systems to work with laser-guided targeting. In partnership with another firm, MFly, Dwarf has developed an optical gimbal module for reconnaissance drones equipped with a camera, thermal imager, and laser designator. This setup allows drones to identify and track targets through multiple methods and designate them for laser-guided strikes. Dwarf's co-founder and executive director, Vladislav Piotrovsky, explained that this approach allows drones to hit targets automatically from up to 3 kilometers away, far beyond the 400 to 800 meter range limit of conventional FPV targeting systems. And crucially, it makes them immune to Russian electronic warfare interference. The integrated system has already undergone successful tests, and production is underway for battlefield deployment. The advantages of these systems are clear. As ammunition supplies tighten and efficiency becomes more important than ever, Ukraine's use of laser-guided drones ensures that every strike counts. A single precision-guided shell or bomb can eliminate a target that might otherwise require multiple rounds or sorties. These innovations enhance Ukraine's ability to destroy high-value assets such as tanks, command centers, and ammunition depots, while minimizing collateral damage and overcoming GPS jamming. Moreover, because drones are difficult to detect and inexpensive to replace, they allow Ukraine to sustain its campaign of precision warfare without exhausting limited Air Force resources. Of course, laser-guided systems are not perfect. Weather conditions can still disrupt their operation, and the process of training enough skilled operators will take time. But Ukraine's progress in modernizing and adapting this decades-old technology highlights its extraordinary resilience and ingenuity under pressure. In a war where electronic interference, resource shortages, and constant Russian attacks test every limit, Ukraine has found ways to turn legacy weapons into modern precision instruments of defense. The rise of drone-based laser designators represents yet another chapter in Kyiv's ongoing story of adaptation, an illustration of how creativity and determination can turn even aging technologies into formidable tools of survival and success on the modern battlefield.